Welcome. This is section 12.4, which is definite integrals. Now, you might say, Miss, what is definite? What is indefinite? Indefinite integrals, you will have a starting point and an ending point. You have a starting point, ending point from A to B, A to B, A to B. And your formulas are pretty much the same as your indefinite integrals. And you will use these definite integrals to, let's see, to find the probabilities, averages, areas under the curve. Let's go ahead and take a look at the first problem here. It says find the total area enclosed by 4 non-overlapping rectangles if each rectangle is 9 inches high and 2 inches wide. Seriously, I have this question in your homework? Okay, let's do it. So I have 4 rectangles. Oops, that's not a rectangle. So let's draw 4 rectangles. Yeah, that's okay. That's a rectangle. So there are 4 rectangles here. I'm going to go ahead and copy this and I'm going to paste it. I'm going to 2, 3, and 4. So what happens is these 4 rectangles are one next to each other. They're not overlapping, and all I'm trying to do is find this not a perfect rectangle is kind of bothering me. Let me go ahead and make these perfect rectangles, the squares, straight lines in the bottom. Okay, so they said the height is 9 inches and the width is 2 inches. So for each rectangle, the area is 9 times 2, 18, 18, 18, 18. So the area of the total area enclosed is 18 plus 18 plus 18 plus 18, which is 72. Now you see why I said I don't know why I have this question in there. Probably because you'll see how you'll find areas under the curves. So that's pretty simple. Let's go ahead and take a look at the next one. Which of the rectangles below are neither left nor right rectangles? Before I go ahead and work this problem, let's go ahead and see what a right and left rectangle is. It says if the function value is same at the left side and right end points, and it's also the height of the rectangle, then the rectangle is both left or right. What do I mean? Well, I'm going to zoom this in, and I want you to see these are my function points, right? The function points are in blue. So this is 1 function point, 2 function point, 3 function point, 4 function point. And let me start with this function point here. You see this function point is on the left hand side, and this is also used as the height of the rectangle. So this is my left rectangle. Here is the function point on the right side, and this function value is used or is the height of the rectangle. This is my right. And for the D, this is going to be the right side. And for E, this is going to be the left side. But look at A here. Look at this weird A, which is in between. So this is in between, so this is neither left nor right. So this A is neither left nor right rectangle. Okay? All right. Let's go ahead and take a look at the next one. From the graph A, you have L3, which is area of the left-hand side. R3 is area of the right-hand side for 3 rectangles. But I also wanted to show you, and what are they asking here? They're asking me to compute the error bounds of L3 and R3. Now, let's simply go ahead and see what they're talking about. So this is my curve, okay? And here, I'm trying to find the area of the curve. Now I can find the area of the curve by forming the rectangles. So this is 1 rectangle, this is 2 rectangle, and this is 3 rectangle. So I'm going to form the area of the curve from these 3 rectangles. 1, 2, and 3. Now because the function value is on the left hand side, this is my left area. Now I have the same one. I can find the area of this rectangle by, let's see what color I can use, by forming the rectangles. 1 rectangle, 2 rectangle, and 3 rectangle. So I'm going to form, these are my rectangles, okay? These are my rectangles here, and this is a right rectangle. Why? Because look at the function value. The function value is on the right side, and that's the height. The function value is on the right side, function value is on the right side. So this is my R 3, right area, because I have 3 rectangles, R3, and this is my L3. Now if you look closely, let me use another color here. If you look closely, when I'm using my left rectangle, I don't get the entire area. You see that? I don't get the entire area. This portion is kind of left out. Let me use a pen here. This portion is kind of left out. But when I use my right rectangle, this extra portion adds in. So you see the difference? But you can find the area under the curve by dividing the areas under the curves into rectangles and then finding the areas of the rectangle. That's what I wanted to show you here, but let's go ahead and do the problem. I wanted to find the area as well. So the first one is going to be the left area. That means this is my function value, this is my function value, this is my function value. This is the height, and I'm trying to find the area of this rectangle. This is the height, trying to find the area of this rectangle. This is the height, trying to find the area of this rectangle. So this is 2, and this each one is 1. So 2 times 1, which is 2. And this is 6, and this is 1. 6 times 1, so this is 6. And this is 8. 8 times 1, which is 8. So the area here is 2 plus 6 plus 8, which is 16. Now let's find the right-hand side. The areas are given to you in the problem, but I'm just showing you how to find the areas, so it's always easy. When I'm finding the right rectangle, I always start with the right-hand side. This is my right side, and this is my height. This is my first rectangle, right side, height, second rectangle, right side, height, third rectangle. So the area of this rectangle, the height is 6. 6 times 1. The height is 8. So 8 times 1. The height is 9. Yeah, 9 times 1. So this is 6 plus 8 plus 9, which is 14 plus 9, 23. And the difference between the left side and the right side is the error. So 23 minus 16 is 7. So your error bound is 7. So if you're taking the left side, you see you have less area. If you take the right side, you have more area, and the error is given to you by 7. Just let's keep it very simple. As you can see, rectangles, areas, subtract, you get the error. All right, let's take a look at this one. So this is the most interesting one. We're going to use definite integrals to find the areas. So A is the area of this, I'm going to use arrows. A is the area of this little area, B is the area of this curve, C is the area of this one, D is the area of this one. Now, very simple. If it's above x-axis, it's positive. Below x-axis, negative. Above positive, below negative. Very good. Now let's see what they're asking me. They're asking me, I'm tackling this one first. They said find integral, which is the area, indicated areas, from A to C. So I'm finding from A, let me erase all of this. Dun, 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 dun. Oh, that's not an eraser. Dun, 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 dun. From A to C. That means they're telling me, hey, add this, and add this. This is positive, this is negative, this is positive. Okay, that's all what they're asking me to do. They're asking me to find the areas from A to C. So A, area of integral A to C is area of A, which is 1.511 minus B, which is 2.413. B is negative, remember it's negative. C is positive. I'm just going to put these positives and negatives. And C, which is 5.122. And all you have to do is simply add these and you will end up with 4.22. That is going to be your area. That's the answer for this one. Now let's go ahead. Let me minimize this one. This looks... Just trying to minimize this so I can work on the next problem. Now let's work on this one. This one says C to 0. That means instead of going from left to right or from smaller number to a larger number, I'm going the opposite direction. I'm going from C to 0, not from 0 to C. You see the difference? It says find the integral. Instead of saying 0 to C, the smaller number is always on the bottom, the larger number is always on the top. It's giving me the reverse. It's saying, oh, hey, go in the opposite direction. When they ask me to go in opposite direction, that's absolutely fine. This is from C to 0 is this area. This is actually positive. What's the area here? The area is 5.122. But because I'm going in a different direction, I will simply stick a negative. So this is same as integral. Let me delete this one. Integral. Delete this one as well. So this is same as integral 0 to C f of x dx, but with a negative sign. So it's the same area, but because you're going in a different direction, you will simply put a negative sign. All right, hope this helps.